All right, hello everyone. This is a little revised portion of the video on the fourth chapter of the formal logic primer that I posted the other day. Unbeknownst to me, when I switched windows and started working in Microsoft Word, Zoom didn't come along for the ride, so to speak. And so there's about 10 minutes of that previous video now that I've gone back and looked at it more carefully where I'm talking through what I'm doing. You can't see what I'm doing, and that's not very helpful. So we're going to work through just this one statement. So I put up a big truth table in the previous, in the slides for chapter 4, looking at different complex statements using brackets to show what's going on in there. So I'm going to work through constructing just this one complex statement on a truth table. Now, as I said in the video for chapter 4 and the videos for chapters 5 and 6, I'm going to be doing more of this sort of thing. So this is just one example about how we do this, and I'm going to work through it somewhat slowly just to demonstrate the various steps we have to use in making this. And then when we're doing chapters 5 and 6, I'll be doing the same sort of thing, maybe a little bit more quickly, but there will be some more examples of this. So we've got this complex statement here, P and Q or R. Now what we have going on here is we've got a conjunction. You can see that in the middle, the and sign. And the conjunction needs two conjuncts, right? It always needs two. One of the conjuncts is P, that's to the left of it. To the right of the conjunction, to the right of the and sign, we've got bracketed material. What goes in the brackets forms one logical unit that the conjunction pulls together, sticks together. And in that set of brackets is Q or R. So we have a conjunction that's telling us that it's true that P is true and Q or R is true. Now remember, a disjunction, an or, is true when one, the other, or both of the disjuncts of the disjunction is true. So Q or R is true when Q is true, or R is true, or both Q and R are true, right? So really what this complex statement is telling us is that it's true that P is true and at least one of Q or R is true. So we're being told definitely P is true, and in addition to P being true, Q is true, or R is true, or Q and R are true, as well as P. So let's see how we represent this on a truth table. So just using Microsoft Word here, I go up, I hit Insert, I need a table, and now, of course, depending on how much you can do about this just mentally and sort of do it quickly, you'll have a better sense of exactly how many columns and rows to put in. As you can tell, Word to make up to, what is it, 10 by 8 table by default. Of course, you can add extra columns and extra rows as you need them. Now, I'm just going to start by making the header row. Now, minimally, when I look at this complex statement, I know I'm going to need at least 3 columns. Why am I going to need 3 columns? Well, and I'm going to go ahead and just center the text here. I know I need a column for P. I'll put on caps lock. I need a column for Q, and I need a column for R. Why? Well, all 3 of those, P, Q, and R, show up in my complex statement up at the top, and I know I need a column to represent each simple statement contained in the statements that I'm trying to represent. Ultimately, we want to represent arguments in truth tables. That's really what we're going to return to in chapter 5 and take a more careful look at that and why we're making the truth tables in the first place. Short answer, they show us validity or invalidity. Now, if I know I have 3 simple statements, I can already figure out how many columns how many rows I need in addition to the header row, which is 2 to the power of n. In this case, n is going to be 3. I've got 3 simple statements. That is 3 different letters that I'm dealing with, P, Q, and R. So I'm going to need 8 extra rows in addition to the header row, because 2 to the power of 3 is 8, right? So I go ahead and add that now. 1, 2, 3, 4, 5, 6, 7, 8 extra rows. And if you're using Word, you just sort of hover your mouse near a column or a row break. There'll be a little plus sign that shows up, and if you click there, it'll add. You can also right-click and then go to Insert. And then if you insert on the table, you can insert rows above or below the current row, or columns to the left or right of the column you're currently in. Okay. So I've got my rows, I've got my simple statements up at the top, and for whatever reason, oh, there we go. I wanted to center that just to make it look nice. That's all. It doesn't really matter if it's centered. It just looks nice if it's centered. Or at least I think so. Okay, so I've got my three simple statements in columns. Now, we also need columns to represent every complex statement that we're trying to represent. Now, in this case, what do we have here? Right along the top, right? The statement that we're trying to represent. P and Q or R. Well, we've got really two complex statements. There's the shorter one. There's just Q or R, right? So I need a column for that because I need to know whether or not Q or R is true when I'm trying to determine if P and Q or R is true. So we'll add a column for just Q or R. Okay. Now, we also need a column for P and Q or R. So we'll add one more, P and Q or R. So when you're dealing with complex statements that are using brackets, so you've got statements embedded within statements, or at least potentially it can be that complicated, you need to make sure that for every little piece, you've got a separate column. So really, in this case, we've got just this one really complex statement, P and Q or R. To really represent the truth conditions of that, ultimately, our final column here, P and Q or R, that's what's going to show us when that statement's true or false. And that statement is really true or false depending on the truth conditions of P, Q, and R being true or false. And we're going to see that whether or not P and Q or R is true is going to depend on the truth values in the column that represents Q or R. And of course, the truth values there are going to depend in the truth values in the columns Q and R. And then of course, when we're trying to figure out whether or not P and Q or R is true, we need to look at our column for Q and R and for our column of P, because it's those two columns that represent the conjuncts in our complex statement P and Q or R. So let's go ahead and start filling this table. So we've got the basics. We've got our header row. We've represented every simple statement in its own column, right? And that's all to the left. Then after our last simple statement, in this case R, we have a column representing each complex statement. In this case, we have a complex statement embedded within a complex statement, right? We have a disjunction embedded within the conjunction. So we need a column for the disjunction and a column for the conjunction that includes the disjunction within it. Now that we want to start filling in the table, we go to the simple statements first. And we always do this. We always fill in simple statements before we do anything with complex statements. One step I'm skipping here, if you're thinking about the rules for truth table formation, I'm not putting in the premises and the conclusion and labeling those in the header row. Why? There just isn't a premise and conclusion here. Right now, we're just representing the statement, P and Q or R. We don't have an argument here. It's just a statement. Truth tables represent the truth values of any kind of statement, simple or complex. And then, as we're going to see in chapter 5, we can use the truth table to check an argument for validity and invalidity. And that's where having the premises and conclusion labeled really matter. So we'll come back to that in the next chapter. Okay, so how do we fill this in? Well, we have to fill in our simple statement truth values. How do we do that? That very mechanical procedure that we can always do the same way. And there's two methods. We can go from left to right or right to left. How do those two methods work? I'll demonstrate both of them just as a way of reviewing some of the earlier material and just showing how those two methods work when we have a truth table like this. So the first method is to fill in half of the far left column, half of the rows in that column with truths and then the other half with falses. So we'll do that now. So what is that going to look like? Well, it's going to look like this. True, 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 true. We've got 8 rows, so 4 truths, and then false, 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 false. 4 false, right? So it's half true, half false. We then move to the next column to the right. We have the number of truths and falses we enter at a time, but we still fill the row. So in the first column, we did 4 true and 4 false. So now we do 2 true and 2 false at a time. So we've got true, true, false, false, true, true, false, false. We then move over a column. We have the number of truths and falses we're entering at a time again. In this case, we're down to our last simple statement, and that last simple statement column always looks the same. It's true, false, true, false, true, false, true, false. We just alternate between true and false until we fill it in. Now we're done filling in our simple statement truth values. We have every possible combination of true and false of P, Q, and R. So in the very first row, under the header row, we've got P, Q, and R all being true. In the very last row, they're all false. And in every row in between, there's some different combination of P, Q, or R being true or false. Here, I'll even put in a little bit of color into the header row just to show that it's the header row. Let's make it blue this time. That's maybe a dark blue. Make it a somewhat lighter blue. There, that's a nice color. Okay, so we've got all our simple statements filled in. I'm going to just delete all of this just to show you that second method of filling in the truth values for simple statements. So I'm just going to delete it. What's that second method? Think about it for a second. What was it? Right, it's just the reverse of that first method. So what we do is we go to the last simple statement column, in this case R, right? Because when we get past R, we're into complex statements. So we'll start with R, and we always want to fill that in the same way. We just alternate true and false, right? It doesn't matter if we've got 2 rows, 4 rows, 8 rows, 16, 32, 128, 256. It's going to be true, false, true, false, true, false, true, false, all the way down. So we'll just start with that. True, false, true, false, true, false. We fill that all in. We then move to the next column to the left. We then double the number of trues and falses we entered at the time. So we went 1 true, 1 false. Now we'll go 2 true, 2 false. So we've got true, true, false, false, true, true, false, false. We then move over the next column to the left. Again, double the number of trues and falses we entered at a time. So that's going to be up to 4 true and 4 false at a time. True, 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 4 true, false, 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 4 false. Look at that. Now, if we had another simple statement, we'd have another column we would have to fill in, so we'd have to follow this procedure another time, but we'd ultimately be doing the same thing. We'd get the same sort of table, a table where we've got columns for each simple statement, and then the rows under those represent some different combination of the truth values on simple statements, right? So now we've used the second method here. We have exactly the same result in these cells that we had from using the first method. We just work backwards. Either way, we get exactly the same result for our simple statements. Learn this, at least one of these procedures for filling in simple statements. Just practice it enough that it's just like a reflex. It's always exactly the same. Whenever you're making a truth table, this part of the truth table is always exactly the same. And so if you just practice this enough and you just sort of drive it in, get it in your brain, you shouldn't ever have a problem with this part of a truth table. This is the simplest part. It can be a little bit tricky, and I know that, so I'm not trying to say that what we're doing here is just super easy, but this is certainly the first step. If you can, get comfortable with this, that you have to have these columns for the simple statements, you're always going to fill it in the same way, you're always going to get the same kind of result, it's always going to look that same way, then you're well prepared to start dealing with the complexity that comes in when we move over into our complex statement columns. Okay, so let's take a look at our first complex statement here, Q or R. And notice that I've arranged the columns here that we have Q or R that comes after so we have simple statements, Q or R, and then P and Q or R beside that. Now I organized it this way just so it's an increasing order of complexity. Q and R is a less complex statement than P and Q or R, right? Because Q or R just has one less part to it than the conjunction that contains Q or R. So if you organize your table this way, that the statements always increase in complexity as you go to the right, then you're just going to fill them in as you go along. You don't have to, though. You can change how they're ordered. We could have done it a different way. And so look, we could have done the table like this. There'd be nothing wrong with it. We could put our more complex statement there and then put the less complex statement there. If that's what we did, we would just have to change the order we filled the table, and we should go over here to the last column first, if that's the simpler one. Then we'd have to move back. So I'm just going to put this back like it was in this I think, more logical arrangement, though it's not absolutely crucial that you do this when you're making your own truth table and try and fill them in. So let's fill in Q or R now. Remember, the disjunction is true as long as one of the disjuncts is true. So when Q is true or R is true or both Q and R are true, then Q or R is true. So to fill in this column, Q or R, and here I'll do a little bit more with colors just to help show where we're working and what I'm talking about. I hope this is helpful. So to fill in these cells, the ones that I've highlighted here, we need to look back to the truth values in the columns that represent Q and R. Because ultimately, whether or not Q or R is true depends on whether or not Q is true and whether or not R is true. So let's take a look at that now. So in this very first column here, right, if we want to know if Q or R is true, we have to look at whether or not Q is true and R is true. In this case, they're both true. When they're both true, the disjunction is true. Remember the truth table for the disjunction. Here, I'll even just draw it really quickly while we're doing this. And so look, I know I need 3, I'm going to have 5. What are we going to have? I'm just going to, I'll stick with Q or R here, just for the sake of sort of showing what's going on. Got true, true, false, false, true, false, true, false. And if I'm doing this quickly in part because this is just the this is the disjunction truth table, right? This is just the definitional one. This is just what a conjunction is. The conjunction is true as long as the disjunction is true, I'm sorry. As long as at least one of the disjuncts is true, right? It's only false down here. It's only in that final column where both Q and R are true that the disjunction is false. Otherwise, the disjunction is true. So let's go back up to our table. So this is just what we're doing, right? We're just looking for the same kind of pattern. Whenever they're both false, the disjunction is false. As long as at least one of them is true, then the disjunction is true. We're just looking for that pattern up on our larger table up here. We just have more stuff on that table. There's more complexity to it. Now, we want all the complexity because we're going to need it when we're checking the argument for validity and invalidity. But as we're filling it in, we only have to selectively pay attention to certain cells at a time, to certain rows and certain columns. So as we're filling in Q or R, we're only interested in these other 2 columns that represent Q and R for now, right? We can just ignore the columns at the very edges. So in the first row, Q is true and R is true, so that their disjunction is true. Second row, Q is true but R is false. That makes Q or R true. Third row, Q is false but R is true, so their disjunction is true. Fourth row, they're both false, so the disjunction is false. And then if you actually just take a quick look down, we have just a repeating pattern here. And you're going to find this in truth tables, particularly when you're looking at simple statements. You wind up finding patterns. And so look, if we go back to our disjunction truth table, the definition here, we know that for any pair of simple statements, 3 out of 4 times their disjunction is true, right? In these 3 rows, the disjunction is true. In this one, it's false. Look, that's exactly what we have here. We have true, 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 false. And then we have exactly the same pattern here as we do up in the first 4 rows. And so if we work through it, right, is Q or R true? Well, it's true as long as one of them's true. And in this row, well, they're both true. One's true in this row. One's true in this row. And then they're both false, so it's false down here. Look at that. So we know from the definitional truth table of disjunction, it's false only 1 out of 4 times when we're dealing with simple statements. It's exactly what we have here. Now we have 8 rows. We have it false twice, and it's true 6 times. Right? It's only false when both disjuncts are false, so we see that twice. Otherwise, it's always true. Okay, so we filled all that in now. So let's go ahead, and I'm just going to get rid of this, the fill, get rid of the color here, because now we need to move on to our final column, this complex column over at the edge. We want to see whether or not it's true or false, right? This more complex statement, P and Q or R. To figure that out, we need to take a look at the columns that represent the conjuncts. That will be P. P is one of the conjuncts, so now we're interested in this first column. Right, I'll just highlight it there. And now we're interested in the column that represents the other conjunct, Q or R. That's this one right here, so I'll fill that in as well. So now, in some sense, we're done with Q and R. We don't really need to look at the columns that represent Q and R independently anymore, because now we're dealing with a complex statement that isn't directly dealing with Q and R on their own. It's dealing with the complex statement Q or R, the disjunction of the 2. Okay, so let's fill in this last column here, the rows in that column. So P and Q or R. That complex statement is only true when both conjuncts are true, which means P has to be true and Q or R has to be true. So as we look and check each row in those two columns that we're interested in, we're only going to fill in the value true for this complex statement P and Q or R when we see true in both columns. So in this very first row, right, row 1, P is true, Q is true. So P and Q or R is true. I think I misspoke. P is true and Q or R is true. So the complex statement P and Q or R is true. Right? It's only true when they're both true, and they're both true in the first row. Second row, same thing. P is true, Q or R is true. So their conjunction is true. Third row, P is true, R is true, so their conjunction is true. Now, when we hit the fourth row, P is true, but in this case, and I'll use some coloring here just to show this as it happens, Q or R is false. So our complex statement is also false. Right? So here, maybe I'll do this. Look at that. So in the first 3 rows, right, they're all true. Our complex statement is true because both conjuncts are true. Now we've hit row 4. One of the conjuncts is false, so their conjunction is false. Row 5, and actually if we look over into the P row, we can do this very quickly. I'll still work through row by row. We see P is false in the last 4 rows, and given that P is one of the conjuncts, it turns out the conjunction is false in all those 4 rows. But here we've got P is false, so the conjunction is false. And in fact, when you're doing this, if you've got a complex truth table, as soon as you find one conjunct is false, that's it. You just fill in that the conjunction is false. You don't have to worry about the other conjunct. In row 6, P is false again, so their conjunction is false. All right, look at that. Row 7, same thing. P is false, so the conjunction of P and Q or R is false. Row 6, or row 8, my apologies. P is false again, so the conjunction P and Q or R is false as well. Now I said that there are patterns that you're going to see on truth tables. Those patterns primarily correspond between simple statements and then the complex statements who derive their truth value from the simple statements. I'm not going to worry too much about teaching you patterns, in part because as soon as you hit complex statements, there are patterns to be found, but it's not really worth your time learning which patterns to spot, because as you see here, we have a conjunction, but it's true 3 times and false 5 times out of 8 rows. So what's the underlying pattern? Well, there is one, but what's really crucial to learn is just how to make the truth table, how to fill in the simple statement truth values, how to add the right number of columns, how to fill in this truth values for the complex statements, and see how they relate to each other. As long as you can do that, it doesn't matter how complicated the statement becomes. You can still fill in the truth table and see all the combinations of true and false. So I hope this was helpful. This was just working through how to construct that one complex statement, P and Q or R, on a truth table. This is really just a kind of supplement or replacement to what I was already doing in that previous video. And we're going to see more of this, this sort of activity occurring in the further videos for chapters 5 and 6.